Okay, this is the review for the Unit 4 test. Okay, so in the first few questions, they're just asking you to find the roots from a graph. So on this one, remember, your roots are where it crosses the x-axis. So you can call them roots. They can be called zeros. They can be called solutions. And they can also, they're located on the x-axis, so they can also be referred to as x-intercepts. Okay, so for this one here, it's counting by 2's here, so x equals -2. And then the other one would just be x equals -10. So again, same thing on this one, you're just looking for where it crosses the x-axis. Okay, now on this one here, it says on the set of axes below, graph the equation x squared plus 2x minus 8. So on this one, I'm actually going to type it into the calculator. Get to y equals. Alright, that took a little bit longer than I preferred. Okay, so on this one here, I'm going to type in x squared plus 2x minus 8. Alright, and then I'm gonna put that 0 in there, because what I'm going to do is I'm going to actually have the calculator help me do it. So on this one, let me get that out of the glare. Okay, I'm going to hit graph. Okay, and I can kind of see that it already crosses at 2 and -4. So 2 and -4, but I'm going to try a second trace intersect. Enter. Okay, so one of my solutions is at 2. The other one is, let's see, try it again, so second trace intersect. I'm going to move my cursor to the other side of the vertex. So over there, okay, and then I'm going to find out what that is. So enter, and you get -4. So just like it looked like earlier. So that's going to be 2 and -4. Now, I'm going to graph this. I can also tell my x-intercept is right here. I'm sorry, my y-intercept. It's -8. That's my y-intercept. And now I'm just going to graph it. Or try to, at least. Let's see if I can get a good angle here. Okay, so it'll be something like that. Okay, so on this one here, again, what I could do is I could subtract 14 to make it equal 0. Okay, so that gives me x squared minus 16 equals 0. And I could do the same thing here. I could come over here, and I could type that in. Okay, so minus 16. And then if I graph that, it looks like it's crossing at -4 and 4. So -4 and 4. Okay, down here it's completing the square. I'm not going to do all of them. I'm only going to do probably about one of them, and then from there you can use that as an example. Okay, so the first thing with completing the square is, and your teacher may have taught you differently, so if it's different than what I'm showing you, you probably need to go talk to your teacher. Okay, so I'm going to take a look at this one right here. Now, I notice that this is not a perfect square, so I'm going to add it to the other side so I can create my own C value that's a perfect square. So I now have x squared minus 8x blank, that's where my C value will go, equals 20 blank. Alright, so now what I'm going to do is, and again, that's where my C value will go. I'm going to create that value for C. So the way you do that is you do C equals B divided by 2 squared. Now my B value is -8. So I'm going to have -8 divided by 2 squared. That gives me -4 squared, which is 16. So plus 16 plus 16. Alright, so now I'm at this point here. So I have to figure out what two numbers will multiply to give me 16, and what same two numbers, because it is squared, it's the same thing twice. So what two numbers will multiply to give me 16 and combine to get -8? Now if you look over here, I can already see I used that number. Another way to think of it is if I just do -8 divided by 2, that'll be -4. So x minus 4. Okay, and then I'm going to square root. So now I have x minus 4 equals plus or minus 6. And then I'm going to just keep solving for x. So plus 4 plus 4. Now, what I end up having here is I have two different situations. I've got a 10 because of the positive 6 and the positive 4, and I also have a negative 2 because of the negative 6 and the positive 4. So those are both of my values for x. So x will equal negative 2 and x will equal 10. So as long as you follow that same format on the rest of them, you should be okay. Alright, on this next problem here, it says Susan drops a ball from the roof of a building. Okay, so here's a building. There's Susan. Oh, let me give her some hair. Doot, doot. Okay, the distance d the ball is from the ground after t seconds is shown by that equation. How many seconds will it take the ball to reach the ground? So if she throws that ball, what I'm looking for is I'm seeing where it hits the ground right here. So this is going to be where y equals 0, or the x-axis. Okay, so if I type that in my calculator, I get 144 minus 16x squared. Okay, so there's my thing. And now I'm going to graph it. And I'm not getting the best picture of it. Let me try a zoom fit and see how that goes. Okay, so that's a little bit better. Alright, so Susan is standing here on the y-axis and she drops the ball, so I'm looking for that intersection right there. I'm always looking for the right side of the parabola, because if I choose the left side here, that means that's going to be a negative number. Alright, so I'm going to make sure I'm going to have 0 and y2, and then I'm going to do second, trace, intersect. I'm going to move that cursor to where the ball hit, so right there, and then enter, 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 and it took Susan... took the ball 3 seconds to hit the ground, so I'm only looking at the x value. So x equals 3 seconds. Okay, on this down here we're doing factoring. So with the factoring, I'm going to use the box. Alright, so I'm going to take a look at this one right here. And again, I'm not going to do every single one. Alright, so on this one right here, I'm going to do the box. So pretty much anytime it says factoring, draw a box. And ignore how wonky it looks right now. Alright, so I know I'm going to have 5x squared here, and I'm going to have negative 2 here. So what I'm trying to figure out is what two numbers will I get here that will add to 3, okay? So I'm going to make my chart. I'm going to multiply my a and my c. So when I do a times c, I get negative 10. So I'm looking to figure out what two numbers will multiply to get negative 10 and then add to get positive 3. So I know I have 1 and 10, and I also have 2 and 5. Well, 2 and 5 can be manipulated to get a 3. I need a positive, so this has to be the positive and this is the negative. Okay, so I'm going to put this in. I'm going to put a 5 here and a negative 2 here. Okay, so now what you have to do is you have to pull the greatest common factor either out this way, or you have to pull it out that way. But you have to pull it out one of those ways. So I notice that I have a 5x squared and a 5x here. Now I always will pull out an x, and I can also pull out a 5, because the greatest common factor of 5 and 5 is 5. Alright, so 5x times what will give me 5x squared, another x. 5x times what will give me 5x? Well, that would just be a 1. And then x times what will give me negative 2x? Well, negative 2. Okay, so my factors here, these are my factors. My factors will be x plus 1, and I'll also have 5x minus 2. Those are my factors. Okay, so now I have to find the roots. So to find the roots, I'm going to set each of those factors equal to 0. So I'll do that over here. So I have x plus 1 equals 0. I'm going to subtract 1, subtract 1. So one of my roots is negative 1. Okay, now I'm going to do it again, but with the 5x minus 2. So I've got 5x minus 2 equals 0. And then I'm going to add 2, 5x equals 2, divide by 5, divide by 5, x equals 2/5. Okay, so again, you'll be using the box on every single one of these. Alright, now this one down here says find the solutions using the quadratic formula. So remember, just like factoring, you need to make sure your equation equals 0. So quite a few of these down here do not equal 0. So for instance, this one here equals negative 9x. So I would have to add the 9x to both sides. Now make sure you have it in that ax squared plus bx plus c. It has to be in that order. So that means I would have to rewrite this as 2x squared plus 9x minus 1 equals 0. So they all have to equal 0. Alright, so I'm just going to solve this one. And it says I need to reduce the radicals if necessary. No decimals. Okay, so this is my A, this is my B, and this is my C. Now notice, I am not including the x squared and the x. That's not part of it. I'm solving for x. I don't want to put more x's in there. Okay, so the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so that's how I can find my roots or my zeros or my solutions. Okay, so I'm going to start filling stuff in. I got the negative from the formula. I have the b plus or minus the square root of. I have my b again, minus 4 times a, which is 2, times c is negative 1. All divided by 2a, or 2 times 2. Okay, so if I work this out from here, I get negative 9 plus or minus the square root of. Now inside here, I'm going to type everything in exactly how I see it. So 9 squared minus 4 times 2 times negative 1, and I get 89. And I'm going to divide that by 4. And that is my solution. 89 can't be broken down. It's a prime number, so I just stop there. Okay, I'll do number 17. Okay, so for 17, again, I'm going to label my A, my B, and my C. Okay, so A is 1, B is 5, C is negative 6. On this one here, I'm going to do x equals, I got negative 5 plus or minus the square root of. I got 5 squared minus 4 times the A, which is 1, times the C, which is negative 6, all over 2 times A, or 2 times 1. Okay, so again, if I type all that in, I get 5 squared minus 4 times 1 times negative 6. I get 49. That's actually a perfect square. So I have x equals negative 5 plus or minus the square root of 49 divided by 2. Now if I keep going, I get negative 5 plus or minus 7 divided by 2, because again, 49 is a perfect square. And then I'm just going to kind of break that out from there. So I have negative 5 plus 7 divided by 2. And if I do that, I end up getting 1. I also have negative 5 minus 7 divided by 2. And if I do that, I get negative 6. So those are my roots, or my zeros, or my solutions. That's where it'll cross the x-axis. Now, on this one here, be careful. You want to subtract 2. That gives you 2x squared minus x minus 15. Now, I'm not going to do this whole one, but what I want you to notice is your b value is now a negative, okay? So when you do the quadratic formula here, because you have that negative 1 right here, when you substitute that negative 1 into this formula right here, that's going to end up giving you a positive 1. That negative and that negative will give you that positive 1. Alright, let's take a look on this side. Okay, so over here we're just simplifying radicals. So I'll just do one of each of these and we'll go from there. So I'll do the 48. Now I do notice it's a negative. So because it's a negative, I'm actually going to have an I in my answer. So let me take care of everything else first. Let me break it down, and then I'll take care of that negative. So I'm just going to look at it as positive 48 right now. So I've got 6 and 8. I've got 2 and 3. Here I've got 2 and 4. And I have 2 and 2. Okay, so I'm going to make all my pairs. I've got one pair here. And then this is another pair. Okay? So I have 2 groups of 2. So 2 groups of 2 is 4. Because of that negative, I'm going to put the I next to it. And then if you notice, I have a 3 left over there. So 4I times the square root of 3. Give me 1 second. The light just turned off. Okay. All right. So now I'm going to look at a different one. I'll look at 72. So on 72 here, again, I'm going to break it down. So I have 8 and 9, which gives me 2 and 4, which gives me 2 and 2. Then I also have 3 and 3. Okay, now this one's a little bit different because if you notice, I can make pairs, but they're different numbers. So I have one group of 2, and I also have one group of 3. So what I'm going to do here is I'm going to multiply 3 times 2, and that gives me 6. Okay, so I'm going to have a 6, and then I have a 2 left over, and there it is. And remember, you can always check these in your calculator. So if you do the square root of 72 in your calculator, you're going to get that number. So if I type in 6 times the square root of 2, I should get the same thing if I've done it correctly. And I have, because they're the same. Okay, down here. Okay, so on these down here, especially when you're just adding, all you're really doing is you're combining what's alike. So when you see that addition sign, just combine what's alike. So for instance, I see a 1 and a negative 3 here. That gives me negative 2. And then the 2i and the 4i will just give me 6i. And that's it. Okay, on this one here, I've got a negative 1. So I'm going to distribute that. So that gives me 3 plus 7i. A negative and negative will give me a positive. And again, a negative and negative will give me a positive. And then again, I go back to what I just did in the first problem. So I'm just going to start combining what's alike. So I see a 3 and a 1. That gives me 4. I also have positive 7i and positive 2i, so 9i. And that's my answer. Okay, on this one here, I'm going to use the box. So I see that I'm doing 2 minus 3i squared. So that's 2 minus 3i times itself, so 2 minus 3i. A very common mistake is to want to just do that and be done with it. This is not correct. Do not do that. It's times itself, so you got to multiply it times itself. Okay, so I'm going to do a box. Okay, so I'm going to put 2 and a negative 3i right here, and a 2 and a negative 3i here. Okay, 2 times 2 is 4. 2 times negative 3i is negative 6i. 2 times negative 3i is negative 6i again. Now here I've got a negative 3 and a negative 3. That gives me positive 9 and then I squared. So remember that I squared is really a negative 1. So I have 9 times negative 1, which would give me negative 9. Alright, so from there I'm going to start combining everything. I have a 4 and a negative 9. That gives me negative 5. And then I have these, and that gives me negative 12i. Okay, on this one down here, I'm going to distribute, 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 distribute. That gives me 7i plus 6 plus 2i plus 4i, and that will give me negative 2i squared. So again, this here is really negative 2 times negative 1, which will end up being a positive 2. So the I squared just kind of flips the sign. Okay, so now I'm going to combine everything that's alike. I have a 2 and a 6. That'll give me 8. 7, 2, and 4. That's 9, 13. So 13i. And that's my answer. Okay, on this one right here, we're just matching. I'm going to use factoring on these, just so y'all can see the box a little bit more. So, I'm not sure what that's supposed to be. I'm guessing it's probably an x squared. I'm going to go with an x squared. Okay, so on this one here, I'm going to multiply the a and the c. And if I do that, I get 10. So I'm looking to see what factors will multiply to get 10 and add to get 7. So 1 and 10 and 2 and 5. I can tell it's the 2 and the 5. Okay, so I'm going to do a box. Okay, I'm going to put the x squared here and the 10 here. Put the 2x here and the 5x here. Okay, so again, I have to make sure that I'm pulling out a greatest common factor either here, or I'm pulling it out here. It has to be one or the other. So I see a 1 right here. So I'm going to pull out a 1 here, because the greatest common factor of 1 and 2 is 1. And then there will always be an x here. Okay, so x times what will give me x squared? Another x, because you'll always have x's here. All right, 1x times what will give me 2x? That's 2. And again, x times what will give me 5x? That will give me 5. So my factors are x plus 2 and the x plus 5. And then remember, your solutions are just the opposite. So x equals -2 and x equals -5. Okay? So that should give you enough information. Now this one is a little bit different. I'll kind of help you on this one. You could look at it as your b value being 0. What I noticed though is these two terms share an x. So I could actually factor out an x. And then x times what will give me back to x squared? Another x. And x times what will give you -3x? -3. So if I were to set each of those factors equal to 0, on this one here I would have x equals 0. And then for this factor I would have x equals 3. So what? This one will go here. And this problem will go there. Okay, let's move to the back. Alright, on this one here, we're determining the number of solutions and if the solutions are rational, irrational, or imaginary. So this is that whole discriminant. So this is my a, my b, and my c. Alright, so if I do b squared, it's -6 squared, minus 4 times a times c, which is 9. Alright, that gives me 36 minus 4 times 1 is 4 times 9 is 36, so -36. That gives me 0. Okay, so when I get a 0, that tells me I'm going to have 2. That's not correct. I'm going to have 1 real solution. So 1 real rational solution. Okay, so if I were to graph this, I would notice that when I graph it, it's only going to touch the x-axis one time. It'll just touch it right there. Okay, on this one here, again, I need to make sure it equals 0, so -5 minus 5. That gives me x squared minus 4x minus 1. Okay, so again, I got my a, my b, and my c. So I'm going to have -4 squared minus 4 times a times c. Okay, so that gives me 16 plus 4, which is 20. Now, 20 is not a perfect square, so I'm going to have 2 real irrational solutions. Okay, on the last one here, I'm going to subtract 2x and minus 2x. So I'm going to have x squared plus 6x plus 12. Okay, so again, I'm going to, there's my a, my b, and my c. So I'm going to have 6 squared minus 4 times 1 times 12. So that gives me 36 minus 48, and that gives me -12. Now, because that's a negative, and remember, that discriminant here is underneath that radical, you can't have a real solution with a negative square root. So this will have 2 imaginary solutions. Okay, so this problem right here, you're definitely going to have one like this on the test. Alright, so for this one here, it says the length of a table is 8 feet less. So length is 8 feet less than its width. So L equals W minus 8. If the area of the table is 65 square feet, write and solve an equation to determine the dimensions of the rectangle. Alright, well, if this is my length, that's going to be W minus 8. And I don't know the W, so I can actually kind of leave that W there. I know they're talking about area, so area is length times width. Okay, so I'm going to multiply these two things, so that gives me W times W minus 8 equals 65. If I distribute that, I get W squared minus 8W minus 65 equals 0. So I'm looking to find out what two factors will multiply to get -65 and add to -8. Okay, so if I do 1 and 65, then I've got 5 and 13. And actually that will work, because that'll give me the 8. Now, 8 is negative, so the bigger number needs to be negative. Okay, so I'm going to do the box here. Okay, so this is w squared. This is negative 65. I'm going to put a negative 13x here, or w, and a 5w here. Okay, so no matter which way I pull out, my greatest common factor is just the 1. Okay, so I'm going to put a w here and a w here. W times what will give me negative 13w? Negative 13. W times what will give me 5w? That will be a 5. So my factors are w plus 5, w minus 13. Now, I'm talking about width, though. The width here would be negative 5 if I solved it. But the width here would be 13. Okay? So that's my width. So my width is 13 feet. Okay? But then they told me the length was 8 less than that. So my length is 5 feet. As far as the equation goes, you can do a lot of different things here that could be considered an equation. I mean, this right here is an equation that would help you solve it. This is an equation that would help you solve it. They're both good equations. Okay, on this last little bit here, it says what is the y-intercept? Remember, the y-intercept is where it crosses the y-axis. So the y-intercept here is 0, 0. The roots, again, are just where it crosses. So one of the roots is x equals negative 4. The other one is x equals 0, which happens to be in the same place as the y-intercept. For transformations, remember everything moves from that parent function. So I can say this moved. And actually, I'm going to find the vertex first, because that usually helps me. There's my vertex. So I get negative 2, negative 4. So that kind of tells me where it moves. So I know it went left 2 and down 4. Okay, so what is the equation of the graph in vertex form? Okay, so I have y equals. Now, this one is a little bit wider. It's going to be a compression. On your test, though, you're just going to need to worry about making this positive or negative. This one is opening upward, so it is a positive. And again, I'm not going to worry about this. I know it's a compression, but I'm not going to worry about that. All right, so then I'm going to have x. Now I've got to put the h from the vertex, so plus 2 squared, and this is the k, so minus 4. All right, and then they want me to do the axis of symmetry. So again, that's just where it gets cut in half, and it gets cut in half at x equals negative 2. Your domain is negative infinity to infinity. In your range, the lowest it goes is negative 4 all the way up to infinity, and that should actually be a bracket here. Okay, all right, so that should be enough to get you started, and good luck.